Welcome to Lesson 5.3, Graphing Radical Functions. In this lesson, we're going to be taking a look at two very specific functions, the square root function and the cubed root function. We're going to be looking at their graphs and some important characteristics of their graphs, as well as reminding you of some of the transformation rules that you maybe forgot since the beginning of the year. First, we're going to take a look at this square root function. So we're going to create a table of values to maybe help us answer this question. So first of all, let's see here. We'll do -2, -1, 0, 1, 2. All right, and we're going to plug those in the calculator. So when I type in and do the square root of -2, well, when I did that in the calculator, I got an error message. Uh-oh. And when I plugged in -1, let's see here. Oh, an error message. Gross. 0. Finally, something I can do. The square root of 0 does, in fact, equal 0, so I'm okay there. Next one, square root of 1. Square root of 1 is 1. I can do that one too. Square root of 2. Oh, man. I could use a calculator for that. That's about 1.4142. Oh, no. That's not a very nice number. Now, is it? So what actually I want to do here is this is not a very nice table of values. It's actually a pretty bad table of values. Plotting these 2 points I could do, but that's not going to help me very much. This point I'm going to have to guess where it's at. So I think it's better if we actually just start all over again. So I'm going to erase this table of values and start all over. So let's think of some numbers that make a little more sense, something that might be easier to take the square root of. Well, okay, so 0. We knew that 0 was easy. Square root of 0 is 0. And 1 worked out really nice because the square root of 1 is 1. But let's think of another number that it would be nice to take the square root of. Ooh, like 4. The square root of 4 equals 2. And then 9. The square root of 9 equals 3. And then how about 16? Because the square root of 16 equals 4. These numbers are a lot better and will create much better a table of values for us to use. Let's take a look at the graph. So we filled out our table. We got 0, 1, 4, 9, 16 for my x values, and that gives me these y values of 0, 1, 2, 3, and 4. So now what I'm going to do is I'm going to go ahead and plot these points on my coordinate plane over here. So let's see here. 0, 0, 1, 1, 4, 2, 9, 3. That's the last point I can fit on there. And then I'm going to connect them together. If I connect them together, what you'll see is that it creates a nice kind of curved line. What this actually is it's like a quadratic equation that's been stuck on its side. Now, some important characteristics of this graph. For example, the domain. The domain. Remember, that's the collection of all the x values that work in this equation. So our domain, if we think about our domain, we can't take the square root of negative values. So no x values can be negative. The smallest one we had, the smallest x value was over here. It was 0. So that is actually the lower portion of the domain. So the domain, x is greater than or equal to 0. Okay, we talk about domain. We also need to talk about the range. What's the range? Well, let's think about this. What is the lowest y value? Well, the lowest y value is 0 as well, and all of the y values seem to be above that. So range, y, greater than or equal to 0. The other important thing to notice is that the x-intercept is at 0, 0. And that actually also happens to be the y-intercept as well. It's at 0, 0, 2. Okay, so let's shift gears. We're going to shift gears and we're going to look at the cubed root of x. And I'm going to create my table of values very much the same way I did before. Be very smart about the values I pick. About all the numbers that I can take the cubed root of. Like I know I can take the cubed root of 0. The cubed root of 0 is 0. And 1, the cubed root of 1 is 1. And let's say not 2. 2, that doesn't work out very nicely. But 8, the cubed root of 8. 8 is a perfect cube, and the cubed root of 8 is 2. And what about 27? 27, the cubed root of 27 is 3. And I could keep going from there. But the one thing you can't forget is that we can actually take cubed roots of negative numbers as well. So we can take the cubed root of, say, -1. The cubed root of -1 equals -1. And -8. The cubed root of -8 is -2. And -27, the cubed root of -27 is -3. This gives me a lot better and a larger table of values. So let's see what this looks like. So if I take that table of values and I start plotting these points, let's see here, -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. If I plot these points and I connect the dots, what's going to end up happening? So I'm going to end up with this really curved line, that has kind of like it almost kind of flattens out. It looks like it's going to flatten out and then continues going. This is what the graph of the third root of x looks like. And again, some important characteristics here. We talked about domain and range with the square root function. We want to do it here with the cubed root function as well. The domain, if you look here, there's no breaks in the graph. There's nothing that's off limits for me to take the third root up. So the domain is all real numbers. Same thing with the range. I know it looks like it's going to level out, but believe it or not, it will take a long time, but this can eventually get to any y value. So the range is all real numbers as well. And there's this point, the x-intercept and the y-intercept. They both so happen to be at the same point they were with the square root function at 0, 0, an important characteristic here as well. So next we're going to take a look at all those transformation rules that you maybe forgot from the beginning of the year that we were talking about. So we have the horizontal shift, moving it to the left or to the right. We have the f of x notation, and then we have an example of what that would look like with the square root function. And then a vertical shift, and what that looks like in function notation, and then in the form. So again, we have these rules and we've seen them before. So reflection across the x-axis and the y-axis, a horizontal shrink and stretch, and a vertical shrink and stretch. Please pay attention to where the numerical values are here when we go back and look at that. So pause the screen right now, make sure you have these written down in your notes. I'll clear off all those marks that I did on here so that you have a clear screen to look at. But take a look at all these right now. Now to a couple example problems. So describe the transformation of f represented by g, then graph each function. So in this particular problem, we see that f of x is the square root of x. So we know what our shape is going to look like. Our shape is going to look like that little bear claw. I like to call that a bear claw. I don't know why, don't ask. But g of x is equal to the square root of x plus 2 minus 3. So the square root of x plus 2 minus 3. So if I look at that plus 2, the plus 2 that's underneath of the radical, this tells me that I'm going to go 2 units to the left. 2 units left. So my square root graph is going to be moved 2 units to the left. And then this minus 3, the minus 3 that's on the outside, that's going to tell me that my function is going to move down 3 units. So from the regular square root, from that x-intercept of 0, 0, and that y-intercept of 0, 0, I'm going to take that point 0, 0. Hold on, let me graph the original function. 0, 0, 1, 1. And let's see here. 4, 2, 9, 3. And if I take each one of these points are going to be moved to the left 2 units and then down 3 units. So that means this point here at the origin 0, 0 is going to move left 2 and down 3. So it's going to go right here at the point -2, -3. Then this next point, 1, 1. Left 2, down 3. It's now at the point -1, -2. The point 4, 2. Left 2, down 3. It's now at the point 2, -1. And then the last guy we have up here, 9, 3. That's going to go left 2 and down 3 units. It now is the point 7, 0. And I'm going to connect the dots there and come up with my new curve. Okay, so now we have the third root of x. So f of x is equal to the third root of x. Let's plot those points. Let's see, we got 0, 0, 1, 1, 8, 2. Those are the 3 points that fit on -1, -1, and -8, -2. So my parent function, f of x, looks like this. So that's the third root of x. And now I'm going to plot negative the third root of x plus 2. Ooh, so what are the transformations? Let's see here. Well, this negative sign tells me that I have reflected over the x-axis. Oh, okay. So reflect over the x-axis. And this plus 2 means that I'm going to go up 2 units. So let's see what that looks like. So let's see, reflect over the x and then move up 2 units. Well, the point 0, 0. 0, 0 reflected over the x-axis is still at 0, 0, so it doesn't move. And then I'm going to go up 2 units. So that point is now at the point 0, 2. Okay, what about the point 1, 1? Well, if I reflect the point 1, 1 over the x-axis, it's going to come down here to the point 1, -1. But then I'm going to have to move it up 2 units. So it actually ends up back at the point 1, 1. Interesting. Okay, we'll go over here to the point 8, 2. 8, 2. If I reflect that over the x-axis, it's now down here at 8, -2. And then we move it up 2 units. So it's now at the point 8, 2. I'm sorry, 8, 0. Let's go over here to the point -1, -1. -1, -1 reflected over the x-axis goes up here to the point -1, +1. And then I'm going to move it up 2 units. So it's now at the point -1, 3. Okay, this point over here, -8, -2, reflected over the x-axis and move it up 2 units. Now, if I connect the dots here, if I connect these dots and make it look the same way, what I end up with is I end up with a curve that looks like this right here, a cubed root that has been reflected and then shifted up 2 units. Okay, now we're going to practice transforming a square root function. So in this problem, write a rule for g described by the transformations of f. So let g be the translation of 5 units right, so 5 units right, and up 2 units of the graph of f of x equals the square root of x plus 1 minus 3. Okay, so first thing we're going to do, we're going to come up with a new function. I'm going to call it h of x. And I know h of x is going to be the translation 5 units to the right. And I'm moving the graph of f 5 units to the right. And if I think of my function notation and what that is, that means it's f of x minus 5. Okay, so f of x minus 5. So how do I do that? So that means that when I write my function, what I'm going to do is I'm going to keep everything the same, except this x right here is going to be replaced with x minus 5. Okay, so what does that mean? That means the square root still stays there, the plus 1 still stays there, the minus 3 still stays there, but the x is replaced with x minus 5. So here, that's x minus 5 inside parentheses right there. So we'll rewrite the function. Let's here, combine my like terms. So x minus 5 plus 1 is minus 4 minus 3. And that's the function h of x. Okay, for my next transformation, I need to move it up 2 units. So what does that mean? That means my new function g of x, the one that I'm looking for, will be my function h of x shifted up 2 units. So h of x has already been moved to the right 5 units. That's this function. That's this function right here. What I need to do now is take h of x and move it up 2 units. So what does that look like? See here, that means g of x is equal to the function h of x, which is this whole thing that we just came up with, that thing, and then we're going to add 2. So my function h of x, which is right here, and I'm going to move it up 2 units. So let's do that final math. Combine my like terms. I get the square root of x minus 4. Let's hear, -3 plus 2 is minus 1. That is my final answer. All right, on to our next problem. So let g be a vertical shrink by a factor of 1/2. Okay, so vertical shrink by a factor of 1/2 reflected over the x-axis. Okay, reflected over the x-axis and then shifted down 4 units. Wow, I got 3 different transformations that are going to happen in this function. Let's go through them one by one. So first thing we're going to do that vertical shrink. We'll do that vertical shrink by a factor of 1/2. And if I remember what that means based upon my function notation, that means take the function and multiply it by 1/2. So we're going to take the function h of x is equal to 1/2 times f of x. So I'm going to take that whole function, I'm going to multiply it by 1/2. So here's what that means. That means it's 1/2 and then times h of x. H of x is this whole function right here. So that whole function right there, so we're going to write it out. Let's see here, 3 times the third root of x minus 4 plus 1. Okay, and then what I'm going to do is I'm going to simplify this expression. When I simplify this expression, I need to remember the distributive property. So I need to multiply this by both terms. So remember that this is one term, the 3 times the third root of x minus 4 is one term, and the plus 1 is the other term that I need to multiply by. So when I simplify this down, I get 3 over 2 times the third root of x minus 4 plus 1/2. Okay, cool. This has been my function that I have now taken care of the vertical shrink by a factor of 1/2. Let's do this reflection over the x-axis. And if I remember how to do the reflection over the x-axis, what that means is I'm going to come up with a new function. We'll call it p of x. And what I have to do to reflect over the x-axis, it is negative whatever the function is that I want to reflect. So I want to take this h of x function that I just came up with, and I'm going to reflect it over the axis. So that's here. That means that p of x is equal to negative, and then I need to write out my h of x function. What's h of x? Let's see. That's 3 over 2 times the third root of x minus 4 plus 1/2. It's this whole function right here that I'm putting inside the parentheses. So now I just have to distribute through my negative sign, and I know p of x is equal to negative 3 over 2 times the third root of x minus 4. Be careful, minus 1/2. Okay, very good. That gets me the p of x function. Let me get to my final function now, g of x. So g of x is going to be the previous function that I was working with. That's p of x. Shifted down 4 units. So down 4, that means minus 4. Okay, so here's what happens. We now are going to write out my final function, g of x. G of x is equal to p of x. Let's see, what's p of x? P of x is this function down here that I was working with. So that's negative 3 over 2 times the third root of x minus 4 minus 1/2. And then we have to do the minus 4. All right, so now all we got to do, we just combine my like terms. So g of x is equal to, well, the only like terms that I really have to deal with is this negative 1/2 and this negative 4. So I can write out everything else. And negative 1/2 minus 4. Ooh, okay, let me think here. Well, 4 is better off written in this case as 8 over 2, so I don't need to bust out my calculator. So I have negative 1/2 minus 8 over 2. That gives me negative 9/2. Now, negative 9/2 is negative 4.5, but improper fraction is much better in this particular situation. There is my final answer. Folks, remember, as always, if you have any questions about this, please do not hesitate to ask, but you can go ahead, get started on your homework.